Hi guys, I hope all is going well and you're preparing for the exam. I wanted to post a quick video here to cover a topic that a few people have asked about in email, and wanted to make it a little clearer here via video. So we talked about a couple of different networks with flux balance analysis. And one of the things that we talked about, in order for a network to be at steady state, you can't have any changes in concentration inside the network. Well, that happens when the fluxes into and out of the network are equal. Well, then some of you guys have said, well, how do you deal with the case of glycolysis where you have glucose coming in but you have 2-lactate coming out? And let me show you how that works and how that example fits into the picture. So the short answer is, if you account for all the carbon entering and exiting the system, then the flux into and out of the system is the same. But what makes the glycolysis example a little more challenging is that you have a glucose molecule coming in, and I'm just showing it here in this particular case as coming in as 3 black carbons and 3 blue carbons, and when it comes into the network, at one step, it gets split into 2 halves. We have these 3 blue carbons and these 3 black carbons, okay? So what if this whole network here is at steady state, then whatever rate it comes in as B, it has to be destroyed at the same rate, which means when B is converted into its next step, which is cutting this molecule in half, then it has to be making it into the 2 halves at the same time, right? So this flux V1 must equal V2 at this step here. So what we also know, though, is if we're destroying a mole of B for every mole of C that we're making, then this rate here, V0, must equal V1 and V2 as well. So this is how we got to this portion of the network that we talked about before. Well, D is made into C here at some rate, which is also at steady state, so that has to equal V3. But this is where things get funny. You have 2 moles coming into C from these two different places, and so if carbon is exiting the system at the same rate that's entering, then V4 must equal V3 plus V1 for 2 times V0, right? So, and this is going to be the same here also for V5. So again, to reiterate, why is this network different from this one? Is because coming into the system, you've got 2 moles of carbon, or two halves of the molecule that get split in half. And when they get recombined in the next step, you end up doubling the flux out. Now, if you keep track of all the moles of carbon coming in, though, and you keep track of all the moles of carbon coming out, you sum them all up by the fluxes, you'll discover that you're still at steady state equilibrium.